All right, we're at the bottom of page 2 of lesson 7.4. So some sequences, they may be a bit more challenging to determine their recursion formula. The best advice that I can give you is try to determine the pattern that's going to get you from term 2 to term 3, and then from term 3 to term 4, and then term 4 to term 5, so on and so forth. So in this example, determine the recursive formula for the sequence 1, 3, 6, 10, 15, 21, etc. What I'd like to do is write out the terms like so. So T1 is equal to 3. Nope, sorry, T1 is equal to 1. Hold on. Thank goodness for whiteout. All right, and now the second term is equal to 1 plus 2, meaning the first term plus 2. You can see that right there, plus 2. All right, I'm going to try this again. T3, the third term, is going to be 3 plus 3. So the second term plus 3. And keep this going. The fourth term is equal to 6 plus 4. So the third term plus 4, so on and so forth. Right? If you notice, the numbers that you're adding on each time, they increase by 1. And they are the same as the term number n. Alright, so now that I've detected this pattern, what I can do is I can say T1 is equal to 1, and then the next term is equal to the previous term plus n. And n has to be greater than 1, as usual. And I've written out the verbal description for you here. Alright, last example, so turn to page 3. This is a word problem. So I want you to read the question, the example, and highlight some of the key points, and then write down what happens to the medicine in the runner's body over time. So answer A. Pause the video and do that now, please. Alright, so you can see I highlighted a couple of key points. Every 4 hours for 3 days, this runner is going to be taking an anti-inflammatory medicine. And the half-life of the medicine is also 4 hours, meaning that after 4 hours, approximately half of the medicine is still in the body. So half of it has decayed, gone away. So describe what happens to the medicine in the runner's body over time. Well, after one dose, the amount of medicine in her body would decay or decrease to half its original amount. So I'm going to write that down right now. So I've written that first part down, but you also need to remember that she is still taking an additional dose every 4 hours. I'm going to write that down as well. So I've color coded, highlighted the information. Adding a new dose of 500 milligrams, that's every 4 hours. Okay, amount of medicine decreases to half, that's the half-life. So for part B, write the amount of medicine remaining after each 4-hour period as a sequence. I'm going to create a table. So I've made this little table with the dose number up at the top going across. This is the number of hours that have passed, and this is the amount of medicine in her body. So with the initial dose, she has 500 milligrams of the medicine in her body. Now, the second dose of medicine, so this is now 4 hours after the first dose, this 500 milligrams has decayed to half. So there's 250 milligrams remaining. But she also adds in a new 500 milligram dose. So that means her total is going to be 250 plus 500, 750 milligrams of medicine in her body after 4 hours. Repeat this pattern for the third dose. So 8 hours have passed. So this 750 gets multiplied by half, and then we have to add the 500 afterwards. Pause right now, fill in the rest of the table for 3 and 4. Alright, so if we were to describe what's happening in her body, we would always take the previous dose, multiply that by half, and then add a new 500 milligrams. So pause and write the recursion formula. And there we have it. The first dose is 500 milligrams, and the second dose is that times half plus 500.